Hi, Kate Meredith here with Glass Education and Kevin McCarran. And Kevin is a retired science teacher from Oak Park and River Forest High School in Illinois, and we also have Katya Gosman on camera duty today. So we want to introduce you to one of the projects that came out of the National Science Foundation grant, Innovators Developing Accessible Tools for Astronomy. And one of the problems that we had to solve while teaching young people about astronomy, people who have blindness or low vision, we needed a way to teach them about a telescope. And typically our volunteers and staff don't like it when people touch their telescopes, especially the lenses and the mirrors. So we needed a telescope that we could touch. And we put Kevin on the job of figuring out how to produce a tactile telescope. And he's here to tell us about it today and give us answer some questions that we might have. So Kevin, tell us about the journey of the tactile telescope and its parts.
The journey of the tactile telescope, number one, is to figure out what it is you want to teach. So the big question is, what is it that you want to try to get across? Because a tactile telescope is a model. No model will be perfect. There are parts of models that will work, other parts of models that won't. So you have to decide what is it that you want them to understand from this. This tactile telescope is a Newtonian telescope, and Newtonian reflector. It will not teach you about the telescopes that they use for the Hubble telescope. It won't teach you about the telescopes that they're using to take the images for the asteroids, but it will tell you basics of how a reflecting telescope will work. So this can teach you some things, it can't teach you everything. So you have to decide first what it is you want to teach, and then how do you want to try and go about teaching it. The next step you have to figure out is, what am I capable of doing with it? So what tools do I have? What tools am I comfortable using? What tools am I comfortable using without losing fingers? And things like that. So these are all considerations that you have to make. And yes, there's always going to be trade-offs in everything that you do once you start making those decisions. So this is the, like I said, a Newtonian reflector tactile telescope. It doesn't have the mount. It doesn't show you how the telescopes move, but it just shows the parts of this particular telescope. Does this telescope work? No. In fact, we made it so that it did not work, so that it was spaced out so you could feel it a little bit easier and get your hands into places that were easier to find. But this will tell you the basics of where the light comes in, where the light bounces, and how does it get there. So basic places that we found things were things like PVC we got from the hardware store, wood we got from piles of junk sitting around places. We have springs and screws that we got from the hardware store. We have a mirror that we got. This one I think we got online, but you can get them at Walgreens and things like that. We also have some other hardware, some other PVC pieces that we got from hardware stores, and the focuser we got from a supplier of focusers. This one happened to come from Surplus Shed, but it is a place that sells telescope parts. And the lens set we got here was from the Surplus Shed, although the things that hold it in place are PVC from the hardware store. So again, the question is, where can you get things, and what's your budget to do those? So right now, this was made for, I think it was around $30, but there are things that you can make that would be much more expensive, and things that you could make that were even less expensive. So the question is, what is it that you want to get across?
That is fantastic. So for our project, we really wanted students to understand how a telescope acts as a tool to gather electromagnetic radiation and to focus it, and then to what happens with that light afterwards. So can you just go through the light path of, let's say I'm a star way over here, and I'm shining down on you. What's next?
So the opening for the telescope is here next to the eyepiece, not what a lot of people think of, but the light will come in here, hit this curved mirror back here. All the curve does is change the angle of the light. It will come together, hit another mirror here, which changes the direction over here to the eyepiece. So the light comes in here, bounces off the mirror, hits this mirror, and then bounces off towards the eyepiece.
That's awesome. And so if I have low vision, or if I'm just trying to learn about a telescope while at a star party in the dark and I don't want to ruin my night vision, I can feel the parts of the telescope. So I'm able to feel the light path. I'm able to feel that this mirror is curved and that this mirror is flat and it's on an angle, and I can tell where it's going and I can put my fingers on it, no problem. So when I get up here to the eyepiece, what am I needing to understand as a person who's just experiencing an eyepiece for the first time?
Well, that's a good question. This particular eyepiece has two lenses. It's a very specific type of eyepiece. This is called a reverse Kellner eyepiece, but there are many different types of eyepieces. What you have here are lenses that will focus the light to a point that will focus light into your eye. These lenses, you can feel, are curved, and where they're spaced and where they're curved will tell where the light goes. But in this case, we didn't really, the eyepiece was not one of the things that I was concerned about teaching. Mm-hmm. It was just that there was an eyepiece here, and the eyepiece may have multiple lenses, and the lenses will have curvature on them to help focus that light.
That's excellent, because what we were doing with this project is we took out the eyepiece and we're putting a camera there, and we're gathering and detecting electromagnetic radiation using a CCD camera, which was a whole nother lesson. So Kevin, I really appreciate you showing us everything about this telescope. I've just a couple other questions about what you did on here. I see at the back of the telescope you have a number of pieces, the mechanism. Can you explain what you were doing down back here? What's that supposed to teach us about the telescope?
So this aligns the mirror so that it is exactly perpendicular to the tube of the telescope, so that when the light comes in, it will focus all the light here onto this mirror so that it changes the direction exactly 90 degrees into the eyepiece. So this has three different adjustments on the back here that can turn this, that can adjust the spacing between the mirror and this piece back here. This piece is floating, it can move. This piece is locked in to the tube of the telescope so that you can change the angle that the mirror is set with these three screws in the back here. Up here, you have this piece has to be exactly 45 degrees to the tube of the telescope, and for that you have three more screws up here that once again you can loosen and tighten to change the angle so that it is exactly 45 degrees between the tube and the mirror so that the light bounces to the eyepiece.
Well, thanks, Kevin. We really appreciate this, and we use this telescope as a model to then help students understand the larger telescopes that they may have gotten to use as part of their work with the IDATA project and the Skynet Robotic Telescope Network. So once they have their hands on these telescopes, then we can help them orient to different types of telescopes, and that was really an exciting move. So thanks a lot.